This meeting is being recorded.
Good morning, everyone. I am Akash Zaman from the Group 3. Today we are here to discuss on the IoT platform Google Cloud IoT Core. I will begin with the introduction to IoT or the Internet of Things. IoT is a network of devices that can talk to each other to the internet. These devices can be anything like smartwatches, security cameras, home appliances, or even machines in factories. The process is very simple. First, device collect data, then this data is sent to the cloud. In the cloud, data is stored and analyzed. After that, action are taken based on the analysis. For example, in a smart home, if temperature sensor detect the room is too hot, it can send data to the cloud and the air conditioner will turn automatically. In agriculture, sensor in the soil can send data about moisture level and farmer can know exactly when to water their crops. So IoT is basically making devices smarter and more useful by connecting them to the internet. Now let's talk about to the Google Cloud IoT Core. The Google Cloud IoT Core is a fully managed services provided by Google. It is done to connect and manage very large number of devices in secure and simple way. There are two important parts of IoT Core, protocol bridge and device manager. The protocol bridge, these help devices connect using a common communication method like MQTT and HTTP. Device manager, this allows us to register devices, manage their identity, configure them, and control security. The main advantage of IoT Core is that it can handle millions of devices at once. It can make secure that it can work smoothly with other cloud services like BigQuery, Dataflow, and machine learning. So, in short, IoT connect our devices to the cloud, and the cloud IoT core is tool that make this process simple, scalable, and secure. Now, further, my friend will continue with the further topic.
Hello everyone, I am Anmol Singh, student of Electrical Engineering. Today I am going to present some key features of Google Cloud IoT Core platform. So one of the main key features is device management. It enables users to securely register, organize and manage millions of connected devices. Each device is assigned a unique ID, authentication keys and metadata, making tracking and control highly efficient. The platform also supports complete lifecycle management, meaning devices can be provisionized, updated, and eventually decommissioned, all from a centralized system. This ensures consistent, secure, and scalable operations, even as the number of connected devices grows. One of another key features is secure communication. Security is a crucial part in IoT systems and IoT core addresses. This uh, throughout throughout secure communications. It supports industry standard protocols like MQTT and HTTPS, ensuring reliable and encrypted data commissions. TLS or transport layer security encrypts all traffic, while JWT's JSON web tokens are used for secure devices authentication without needing passwords. The platform also integrates with Google Cloud IAM for fine-grained access control, so only authorized users and devices can interact with this system. Additionally, devices are limited to publishing data only, which helps reduce attack risk and improve overall system security. And one of the most important key features is data integration. Finally, IoT Core excels in data integration by working seamlessly with other Google Cloud services. It uses Cloud Pub or Sub as a high-speed messaging bridge between devices and cloud services. Data collected from devices can be processed and analyzed in a real time using BigQuery and Cloud Dataflow. This supports both batch and stream processing, and results can be visualized using Looker Studio. The integration with AI or machine learning tools also enables predictive insights and automation. This powerful data pipeline allows IoT Core to securely handle millions of events per second at a scale. Thank you everyone. From here on, my group mates or teammates will continue the rest of the presentation.
Good evening. Good evening, everyone. My name is Bismar Shauki Widodo, and today I'll continue the presentation by explaining the example of IoT core application in everyday life. The very example is in smart agriculture, where we can see this in with soil moisture and temperature sensors. Now, one of the Cloud 3 key features there we already mentioned can be useful for the sensor system operation, where the first one is device management, that which ensure that fast fleet of soil sensors scatter across a farm, so that it can be registered, authentic, and maintained centrally. As for the secure communication, it established through protocols like MQTT or HTTP, where IoT Core acts as a gateway that provides robust authentication using certificates and TLS encryption. This, of course, allows the telemetry data that to be safely and reliably ingested into the cloud. And finally, for data integration, it will start to take over as the data arrive into the cloud, where the core automatically routes the data to the cloud pub or sub before it integrates into the BigQuery, where the data will be stored for historical analysis and served as an input for AI or machine learning model. This, of course, will allow the AI to predict precise irrigation needs based on the several factors such as soil condition, weather forecast, and historical pattern. This is an example of the IoT core application in smart agriculture. We have this greenhouse right here, complete with the smart plant management sensor, where the sensor will collect several data around the greenhouse and process it so it will manage the plant growth cycle based on several factors. The second application, if we can see, the second application of the IoT core is in smart city, where we can see this with intelligent traffic management, where of course the device management will handle the life cycle of potentially thousands of traffic signals, roadside units, and vehicle counting sensors. And for the secure communication, we will use it as sensors that continuously stream real-time data on vehicle counts, average speed, and congestion level. As for while ensuring high volume mission critical data is encrypted. As for data integration, of course, they are seamlessly published to the massive real-time traffic data stream to CloudPub subtopic, where it will ensure a buffer for high data velocity and reliable delivery. The data is then funneled to the BigQuery, where the city's historical and real-time traffic data will be combined with external factors like event scheduling or weather. And of course, an AI machine learning model then runs on this data to predict future congestion points or optimize traffic flow. And this is the example of of the IoT core application in smart city. Is basically through smart city app, where the app, of course, will manage the facility across the city. One of them include traffic management through several input and output process, as shown here. That's all today, It's all today. Forgive me if I made several mistake. As for the next material, I will let my friend Raisa to explain.
Okay, hello everyone. My name is Raisa Sadinarendra, and now I will explain about the advantage and the limitation. For the advantage, the first one is scalability. Google Cloud can handle large amount of IoT data and easily scale up or down depending on needs. The second one is the integration. It works smoothly with other Google services like BigQuery, AI or ML, and analytics tools for deeper insight. The next one is the security. Google Cloud provides strong authentication, encryption, and compliance standard to keep IoT device and data safe. For the limitation, the first one is the cost. Google Cloud can be more expensive and become expensive when the data storage and processing demands grow. The next one is the complexity. Of course, Google Cloud requires technical expertise to set up and manage effectively. And the next one is the connectivity dependence. IoT device needs stable internet, performance drops, or poor connectivity. So, the conclusion is Google Cloud provides a powerful ecosystem for IoT application offering scalability, intelligence, and security that make it highly suitable for large-scale enterprise IoT projects. Its ability to integrate with advanced AI or ML service is particularly valuable for real-time analytics and decision making. However, developers must also consider the challenge. The cost can be escalated quickly without careful design. Stable internet connectivity is essential for functional, and the learning curve can be steep for those new to cloud performance. In practice, Google Cloud is most effective when used for large data-intensive IoT systems such as smart cities, industrial monitoring, or health solutions, where its strength outweighs its cost and complexity. On the other hand, for small-scale IoT projects or development in areas with poor connectivity, like wake solution or hybrid approach, edge plus cloud, may be more practical. Ultimately, the decision to use Google Cloud for IoT depends on balancing scalability, cost, complexity, and infrastructure readiness.